We already looked at some and type compound inequalities. Now we're going to look at some or problems. And really when we're solving these, we're just going to treat them like we've got two separate inequalities and solve them like we normally would. We're going to put them on the same graph. So if I'm looking at number 5, for example, I would add 7 to both sides. And then that's x is less than or equal to 9 plus 7 is 16. And then if I'm solving the other problem, I'm dividing by -3. And then because I divided by a negative, we're going to flip that sign around. And -27 divided by -3 would be a positive 9. Let's see, 9, 10, 11, 12, 13, 14, 15. I barely fit them on here. 9, 10, 11. Okay, so I need a filled in circle at the 16 because it has a line underneath it. And I need an open circle at the 9 because that does not have a line. I need numbers that are greater than the 9 but less than the 16. So greater than 9 but has stayed less than the 16. So it's everything in between here. And that's weird because that should be an and problem. Typically when we have an or problem, it's going to shade one way or the other. So this actually should have been an and problem. But we solve them the same way. On number 6, we're going to divide both sides by 11 on this first one. That's -2 is greater than x. And I'm going to rewrite that so I have x is less than -2. Notice that the pointy side still faces the x on both. On the second one, do -4 on both sides. And x is greater than 0. So let's see, let's put 0 here. I guess I could have scooted it down a little bit. Let's see, I need open circles at both. So open circle at -2, open circle at 0. I need values that are greater than 0. So that's to the right of 0. And I need values that are less than the -2. That's to the left of the -2. So this is a true or problem where I cannot have both. It's either going to be over here or it'll be over here, but it can't possibly be both. So it's one or the other. And then if we look at number 7, I'm going to subtract 9 from both sides. I get 2x is greater than 8. And then divide both sides by 2. X, we divided by positive, so the sign can stay, is greater than 4. Go ahead and solve the other one. -10 from both sides. 5x is less than 0. It's okay that we get a 0 there. I know that confuses us sometimes. Divide both sides by 5. X is less than 0 divided by 5 is 0. So we need a 0. 1, 2, 3, 4. And I need open circles at both 0 and 4. And I need values to the left of 0, less than 0, and greater than 4, so to the right of 4. And again, the answer can either be less than 0 or greater than 4. It can't be both. So that's why it's an or problem. You're going to have an answer that fits down here or an answer that fits up here, but not both. And our last one, number 8, let's add 6 to both sides. So we have 3x is greater than or equal to 6. And then we divide everything by 3. So we get x is greater than or equal to 2. And here we're going to subtract 5. We get 4x is less than or equal to -8. -3 minus 5, watch your integer rules. Divide by 4. I get x is less than or equal to -2. So I need, let's see, -2. Okay, I need a closed circle at both. So closed circle at -2, closed circle at +2. I need values that are greater than the +2 and less than the -2. Then any notes you want to write off to the side to help you remember which way these should go, you can do that.